Hello everybody, I'm Nick, and in this video I'm going to show you how you can get started with Entity Framework Core in .NET. You see, in this channel I have many advanced videos, but I want to go back to the basics on some topics and provide ways for you to get started with some fundamentals like EF Core, Dapper, and many other things. So expect more videos like this, and if you are more of a beginner, subscribe so you don't miss any of them. But in this video I'm going to show you how you can take a project that doesn't have any database. In fact, we're only going to have an in-memory database, and we're going to integrate with Entity Framework Core. Now, what is EF Core? EF Core is what's called an object relational mapper, or an ORM, which allows you to take the domain objects you have in your C# code, and don't think domain as DDD, think more like models, and use them to save and retrieve things from a database, and in this case, without actually having to write SQL in almost every case. Now, if you want to do some very, very advanced stuff, you can still write SQL. You're allowed to do that with EF Core, but for most cases, you'll be just writing link, and that link will be converted into SQL through EF Core. You might have heard through the years that EF Core is a very slow piece of technology that you generally use in production, but the truth is in 2024, 2025, EF Core is actually very, very much optimized and can hold its own against solutions like Dapper. So don't feel like you can't use this, you absolutely can. Now, in this video, I'm going to show you how you can use EF Core with Postgres, which is my favorite database, and we're going to do that on the cloud. We're going to use AWS, and this video, in fact, is sponsored by AWS. So if you want to find out how you can get $50 free credit, check the link in the description. Everything we're going to see today is part of the free plan, free tier, so you don't really have to pay anything, but you can use any other database that you want and in any other environment. It's just that I want to show you how you can actually integrate with a real database running somewhere outside of my PC. So I'm sure to have here, because I want to first introduce you into the project we're going to be implementing EF Core in. So I have what's called the Movies API, and I'm using minimal APIs over here in a bit of a structured way to create a create endpoint, get all, update, and delete. It's a CRUD API. In many ways, it's conforming on the REST API standard, but don't think too hard about it. Just think that this is just a CRUD API that can operate on a resource, and that's the resource we're going to be building a database for. Now, if I go over here in the movie service, what you're going to see is I have things like validation and retrieval and updates and deletes and everything, but I'm not dealing with a real database. Instead, what I have over here is I create an in-memory list that contains our movie, and the movie model contains just 3 properties. I want to show you how you can get started in a very simple way before we go into more advanced topics. If you want to see an advanced video on EF Core, leave a comment down below, let me know, and I'll make it. But the idea is that if I go ahead and I just run my API over here, and by the way, this code will be in the description down below if you want to get it for free. So my API is running, I can go in Insomnia, which is what I'm using to call my API. And if I say get all movies, I'm going to get nothing. There's no items in this collection. But if I say create a movie, the classic Nick the Greek from 2012, then as you're going to see, it is created. I have an ID, I can get that ID, and then I can go and say get all movies, and I'm getting all the movies. In this case, we only have the one we just created. If I say get movie and it doesn't exist, I'm going to get a 404 as expected. But if I use this ID that I know exists, then I'm going to get the resource back, and then I can say delete. So delete this. Okay, it is deleted. And if I try to delete a deleted resource, as you're going to see, I'm going to get a 404. All that is very simple and it makes sense. Now, what we want to do here is we want to add Entity Framework Core and the ability to save all that in a database in .NET. So the first thing I need to do in here is to find the NuGet package for Entity Framework Core. Now, if you search Entity Framework Core, you will see many NuGet packages over here, and it can actually be overwhelming. Don't worry, we're only gonna need 2 of them for this video. The first thing we need is the main package for the database we're going to use, which is PostgreSQL. Now, PostgreSQL in terms of NuGet packages is called npgsql because that's the most popular core library that deals with Postgres. And we're going to go ahead and add this NuGet package over here. And because Entity Framework Core will also scaffold the SQL needed to design our database, the SQL for the database through C#, we're going to need a design package. So we don't only need the Entity Framework Core, but we also need the Microsoft.entityframeworkcore.design NuGet package. So we're going to add this too. So in terms of packages, that's all we need to get started and basically do everything. But we will also need a CLI tool, a command line interface tool, to interact with things like our migrations and executing those migrations. You can do all those things in code too, but almost always you will do them through the CLI. So I have my CLI here, and what I'm going to say is .NET tool install. I want to say that this is a global installation, so I can access that command from everywhere, and then .NET EF. If I didn't choose global, it would only be applied to this specific project. So I'm going to say this. Now, in my case, I already have it installed, so it's not going to really do much. For you, this will just install .NET EF on your PC. And after that, you will be able to say .NET EF, and you should see a unicorn because that's the symbol of Entity Framework Core. And then we can do many things such as migrations and interact with the database. We're not going to touch any of that for now. What we are going to do is we're going to create the database we want to be interacting with. Now, like I said already, I am going to use AWS for this, but you can use any other way to get a Postgres database that you want. In my case, I'm going to use RDS, which is a managed relational database, so I don't have to manage it myself. As you can see, I already have a DB instance running. I'm not actually going to create one as part of this. I already have created one. The reason for that is it does take some time, and I don't want to bore you with just waiting, seeing this to complete. So what I'm going to do is I'm going to go to the bottom and say create database. That's what I would do. And then you want to say standard create. We're going to choose, in my case, Postgres, but any other database would work. Then you want to choose the engine version. There's many engine versions supported. This heavily depends on the company you work for and what you want. You can always choose latest, or you can always choose the latest major. Then I'm going to choose the free tier because I don't want to pay any money for this. And then I'm going to skip all the way here, and you can give a database identifier. Then you can create the username that you want to access the database with, or you can use the AWS secret manager as well. But to keep it simple, I'm just going to use a self-managed password. You can go ahead and type the password you want over here and it will be generated. You want it to be something strong and a bunch of other configuration that doesn't really matter. You want to make sure you turn off auto scaling here just because this is just an example. And we don't need to connect any EC2 compute resource. In this case, if you want to access it, you also want to say that, yes, please have public access to this resource. And then you can choose your VPC security group, availability zone, and at the end, you just say password authentication, turn off the performance metrics, and then just say create. Now, I've already done that, and as you can see, I have a database here. That's the database I'm going to be interacting with. But even if you followed all these steps, you won't be able to access this database. You will have to go to the security groups over here, and you will have to select the security group ID. And then you want to go down to inbound rules, and you want to edit those inbound rules. Now, if there is any rule over here, what you want to do is you want to delete it. You want to say add rule, custom TCP. You want to choose the port, which is 5432 for Postgres. And then you want to choose where you want the traffic to come from and where you want to allow it. In my case, it is my IP. I'm not going to click that because I don't want you to see my IP, but you could say my IP or anywhere as well, but be careful with anywhere. And then just say save rules and traffic will be allowed in this database. And with all that done, you should be able to connect to Postgres. What I'm going to do is I'm going to connect through my ID because there is a feature I can use to interact with my database. So I'm going to say connect to database, add data resource manually, select Postgres, the host I can get from AWS. The username in my case is the default, it's Postgres. The password is subscribe, and don't forget to subscribe. And after that test connection, all works and I can connect to my database. Here we go. So it is connected and I can see my database over here, and I can go and say if I want to create a new database, I'm going to call it Dome Train, which by the way has a full course on EF Core, and it is part of the free trial we offer, the 7-day free trial we just launched on Dome Train. So you can check that out as well. But now the database has been created. I do want to go ahead and say, hey, make it visible over here. So let's just refresh that, click on this, select Dome Train, and everything will be created in this database. We're going to go ahead and select all the schemas, and it's going to be in the public. Bit of a setup, but now we have a database we can publicly access and use for this purpose. Now, what I'm going to do is I'm going to make the core of the whole database operation in EF Core, and that's called the DB context. Now, the DB context is what's going to contain all the DB sets, that's what Entity Framework calls them, and each set represents a table. Let me just give you an idea of what that looks like. So I'm going to go here and say, create directory, database or data. You can choose to name it whatever you want. And I'm going to go here and say, app DB context. So create my DB context, and that will implement the DB context or extend the DB context class. Now, a few things I need to do on this DB context, and usually if you create a project with EF Core from scratch, it will have this by default, but in this case we don't, so we have to add it ourselves. So we want to have a public constructor, and we're going to say DB context options on that app DB context. So options over here, and we want to call these options, and we're going to use them to call the base constructor. Once we do that, we have a couple of ways to configure the connection string for this database. I could say override on configuring, and I could use the options builder to say use npg SQL over here. And if I do that, I could add the connection string of my code over here. I can also inject the options in here and do it like this. I'm not going to do the on configuring part. Instead, what I'm going to do is I'm going to show you the other way you can use this, which is in the program.cs, you can come here and say builder.services.add DB context of type DB context. And then in here, you can say options builder dot, and it's the same on configuring approach. So you can say use npg SQL. And because we have access to the options here, I can say configuration, and I can get the connection string. So the DB connection string, let's say, and this is definitely not null. Here we go. Now I'll go ahead and add this into the app settings.json. So I'm going to say DB connection string, and we're going to configure all the parameters. The first one is the server. So we're going to add the AWS server here. The port is the same. The database is Dome Train. The user ID is Postgres, and the password is subscribe. Here we go. We have everything now. And now that's the minimum configuration needed for us to start interacting with the database. Now, what I want to do here is I want to create a DB set to represent the movies I want to store. So what I'm going to say is DB set of movie called movies. And that is how I represent my movies in my database. That is it. That's all the information EF Core needs to look into this model and say, all right, I build what I think you want me to build to represent this model in the database. Now, in our case, the ID here is the key. And I could leave it up to chance and hope to see what EF Core can do, but actually EF Core has some attribute support. So I can actually say that I want explicitly this ID over here, this GUID ID called ID, to be the primary key for my database. And with all that done, I can now go to the terminal and scaffold my database. So how am I going to do that? Well, I'm going to say .NET EF migrations add init. And this will be enough for the tool to look into the project and try to create those migrations. Migrations are just C# files that run SQL. So if I go over here, you can see I have a new folder called migrations. If I click on it, we have the AppDB context model snapshot with some details about the snapshot of the database. And then we have all the code needed to create things like the table that we need, a UUID column table with text and integer. And you can specify custom limits as well. So if you don't want the text to be unlimited, you can say max length on that using an attribute or using settings on the app DB context as well. But that is going a bit more advanced. And if I go back here, and then we have both an up method, so when you run the migration, but we also have a down method when you want to revert a migration. So it knows how to delete what it created. But just creating this text is not enough, because if we go over here, if I just say refresh, we don't really have any table. We need to actually tell to EF Core to execute this. So how are we going to do that? We're going to say .NET EF database update. And now it's going to take all that information from that project and run, as you can see over here, the SQL. So now if I go to the database and I refresh, I have two tables. I have the movies table I just created with the ID, title, and year of release. Everything made for me. I didn't have to write any SQL. And I also have the EF migrations history. Why is that? Well, that's because EF Core needs to remember which migrations it has run, because nothing would stop me to go here and say, okay, .NET EF database update again. And what, should it run them again? No, it's going to detect that, hey, this database has already been migrated to the latest version, so no migrations were applied. It's a very simple mechanism to keep track of everything, but it's very, very powerful, and that's what we basically depend on to not make any mistakes. But once we have all that, all the SQL stuff on setup is already done. And of course, every time you make a change, you have to remake a migration, you make an update, and then you run that update. But now that we've done this, what I can do is I can go into the movie service, and instead of having a list, I can inject the private read-only app DB context. And my DB now, the DB context, will be represented and injected like this, or injected through the constructor, and any movie-related database action I need to make, I make it through this DB context. Now, a few things about registration over here. By default, DB contexts will be added as scoped services. So as you can see over here, that would be the default. That's why it's gray. However, you can go ahead and change them to transient, which means a new instance of the context will be created every time, or a singleton. Doing so can be very, very dangerous if you don't know what you're doing. It heavily depends on the database provider and your configuration for the entire application. For most cases, leaving it as scope is what you should be doing. And if you really, really know what you're doing, then you really don't need me to explain why you should choose transient or singleton. It is way more of an advanced topic. It is not for this video. But it does mean that because now that is a scoped service, we should also change the movie service to be scoped as well, because you can't have a scope being injected in a singleton. This means it will just be captured as a singleton as well, and nothing will basically work. So this project will actually fail. And same goes for the validator, which by default is scoped as well. And you can see that if I hover over here, it is scoped too. So with that configuration, I can go ahead and add my code. So what do I want? I want to add the movie that's being created when the user is adding it. So we want to say db context.movies.add the movie. That, however, will not run anything against the database. This just tells to EF Core that, hey, I have this representation of my movie in memory. When I eventually tell you to save those changes, add this change into the database, convert all that logic into SQL and execute it. In order to trigger that actual execution, we have to say dbcontext.save changes async. And only then the SQL will be generated and these queries will be executed against our database. And by the way, if you were doing this properly, you would also pass down the cancellation token all the way from the controller or the request, which would go over here, but we don't need this for this case. We want to keep it simple. So now we have enough to create the movie in the database. How about retrieving it? Well, the good thing about EF Core is that it has a very much a link approach to it when you operate against the database, which by the way, in many ways is its downfall and the criticism, because you're only as good with EF Core as your ability to understand how this link will be converted into SQL. Again, something we cover extensively in our 8-hour course on EF Core, and I couldn't possibly explain everything in this video, but I will give you a hint on how to think about it. So I'm going to say DB context over here, and then I'm going to say movies because I'm looking for a movie, and then I'm going to say find async, and I'm going to say find async because I'm looking using the partition key, using the key. And if you have a composite key, you can pass an array of keys here too. So I can say find async, and I can turn this into await, and this will now return a nullable item. If it finds the movie, it's going to return the movie. If it doesn't find the movie, it's going to return null. Now, another approach to this, and what you could technically do, is you can say first or default async. So use the async version of the first or default link method and say ID equals ID. You can say that. And you can also say single or default async. Now, a bit of a note here for single or default and first or default, and I will explain how they differ from a find async too. Single or default as a link method makes sure that there's only exactly one item that matches this query or none. And that's the only happy path, which means to guarantee that there's exactly one. It doesn't stop on the first match, but it also has to continue scanning the data source because there might be a second one. And if it finds a second one, then that's when we stop. First or default doesn't have to do that. So if you think of how this will be converted into a SQL, if it's SQL Server, it's going to use the top query. And if it is Postgres, in this case, it's going to use the limit clause. In the first case, the first or default async will actually use a top 1 or a limit 1, while the single or default async, because it needs to make sure that there is no duplicates as well, then it will use a top 2 or a limit 2. So first or default in most cases will be more performant. However, because in this case we're using a primary key and is indexed, you're not really gonna see a difference in performance. But you will see a difference in performance when you use find async, because find async is doing some magic behind the scenes to keep the entity in memory as well and not actually go to the database. And it's actually explained here. If the entity with a given primary key is being tracked by the context, so the context is tracking it, then it is returned immediately without making a request to the database. And this means it goes in memory and it doesn't have to go anywhere to retrieve it, making it very, very performant. This won't happen with the first or default async, at least in my experience, I haven't seen it. Then to return the get all, what we want to say is dbcontext.movies again, .to list async. And this will return a list of all the items. Now, a note here, if you want to filter this data, you can say where, for example, x.year of release is more than 2000 to find a movie from 2001 onward. So you can have queries here, and this will be taken into account in your link conversion and your SQL conversion. But I also want to point out that you might want to use the as no tracking instruction, because by default, when you run queries like this, EF call will try to track them to see if you operated on them, if you change the value, and next time you say save changes or update it, you make that change and you update it too. You can have performance improvements with as no tracking. There was a bug in previous .NET versions, but now I think it is fixed and you don't have to worry about it. But this heavily depends on if you want to track this resource for changes. If you don't want to track this resource for changes and you just want to return it to the user, then it might be wiser for you to just say as no tracking. Your queries will be faster. Then on update, what I'm going to say is dbcontext.movies.update. Again, this update gives you the instruction that I want to update this movie. So existing movie. And then in the end, I'm going to say dbcontext.save changes async. Now, the way this method is implemented previously is that it checks if the movie actually exists, and if it doesn't exist, it returns null. What we could do here is we can actually get the result count of save changes async, because this method returns the count of how many entities were affected by this change. So what we can say is a result more than 0, then return the movie, otherwise nothing was really affected. So return the default. Here we go. And if I do that, I can then delete all that and save a hop. So here we go, the movie here. And then in the end, if I want to just delete that item, I can say two things. If I have the object in memory, I can say dbcontext.movies.remove, and that will work. Of course, you're going to have to save afterwards. But in this case, we want to do it query based. So what we're going to say is var result dbcontext.movies. And I want to match the item I want to delete. So x is x.id equals the ID, and then you want to say execute delete async, and that is it. And with all that now, if I go ahead and I run my application, here we go, the application is running. I am going to go to Insomnia now, and I'm going to get all the movies, and as you can see, we have no movies in the database, so it is empty. If I say get me a movie, 404, no response, but I can now create a movie, so let's go ahead and make it. So movie was created. As you can see, in here, you can see all the queries executed and generated based on the link and all the code we have. So this add call that we have is turned into this insert over here, which parameterizes the queries, make sure they're SQL injection safe, and then they just execute them. And the other thing about the retrieval of the movie, as you can see, limit 1, not limit 2. So on the first match is going to just return back, being very, very efficient. And now that we have this movie, I can say, I get the movie. I'm going to get the ID over here and see that we can retrieve it. Here we go. It's being retrieved. Get all the movies. And by the way, this will be even faster. So it's 33 milliseconds over here the first time, but now it's in memory with this find async. So if I run it again, 24, 21, it is pretty efficient. Then we have the get all movies, so we can list it. And then in the end, we can just delete it. Here you go. So everything works. Let's just test update too to make sure that it's working. So I'm gonna get that over here, use it, and then change the year of release of this movie to 2023. So update, and as you can see, this now has been updated. if I say get all movies that has been updated. The great thing about this, obviously, is we didn't have to write any of this SQL. The criticism of this is, of course, that developers should really know SQL. It is a skill you want to have, because when this eventually goes wrong, and it probably will go wrong if you're not familiar with it, you will need to take a step back and say, okay, do I know enough SQL to understand why this is happening? So in my opinion, yes, this is great to use, but you should absolutely know how to do this all by hand if you needed to, because this is just a convenience. It is not a replacement for SQL knowledge. Now, there's many things you can do with EF Core, and there's many advanced routes you can take this. For example, if you want to customize your model any further, you could go here and you can say override on model creating, and you could say, for example, model builder dot entity dot movie, and you can say that this movie has an index on a property. So it has an index, let's say, on the year of release for some reason. And if you were to do that, this will be taken into account. So if, for example, I went there and I said add migration, added index on year, this will generate SQL for that to build that. And when I say update, it will execute it. So this is being run now. It's being built. It's being run. Here we go. It all worked. And I can see that I now have 2 migrations executed. And if I go into the movies, you can see I have 2 indexes. If I refresh this, I have one, the primary key, and I also have one on the year of release. All that done for me, and you can see the extra thing over here. Now, I think this is a good point to stop the first video. If you want to follow up on a deep dive on this, please let me know in the comments down below, and I will make this. And as always, the code is in the description down below, so if you want to grab it, just click that link. But now I wonder from you, do you have experience with EF Core, and would you choose EF Core or Dapper in production environments? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.